All right, we're on. Ha, cool. And only a minute late. Excellent. What's up, everybody? Thanks so much for coming along. I hope you enjoyed lunch. I hope you've enjoyed the start of the sessions today at NDC Melbourne. I thought it was a wonderful opening talk on AI, and I'm going to hopefully not cover exactly the same stuff, or at least going to talk about it in JavaScript and not .NET, because I don't know any .NET, so happy about that. My name's Nash. I'm a developer relations engineer at a company called DataStax. DataStax is building like a platform for building AI, generative AI applications. So we have two parts of that. One side of which is our database, AstroDB. It has a vector index. It's a document NoSQL store, and it's really good, I think, at vector indexing as well. And the other side is Langflow. Langflow is like a drag and drop builder for building AI applications, and I will try to remember to show you that at the end, because I think it's a useful tool to go and experiment with, if not do more stuff when you want to build with these. But I guess I kind of want to start by addressing like why we want to build with these things. Again, Steve in the morning in the opening keynote did show a whole bunch of exciting things that you can do with this stuff. And the question is maybe then, why do we want to do this in JavaScript, or why do we want to be building this right now? Firstly, this slide is getting slightly old, but I still kind of think that generative AI is basically brand new. It's about 2 years since, at least for us as developers, it's about 2 years since the GPT 3.5 API was released by OpenAI, and that was the kind of first time that we could properly go and build things on top of this. And it is changing just all the time. We are getting new models, new ways of working with those models, new inputs and outputs, modalities, all that kind of stuff. It is changing all the time, and that's just exciting, but also a little bit something to keep up with. I do always think that as long as you kind of try to learn the fundamentals underneath a lot of these things, then kind of understanding the updates, understanding the new stuff becomes easier. And so when I show demos or code or anything like that, I do attempt to forego frameworks and things like that. They're going to kind of get in the way. And I try and use it as lowish level as possible. If it's an API, I'm not going to use Fetch to talk to it. I will use the SDK, but things like LangChain, Llama Index, and other Vercel's AI, that kind of stuff, all really useful stuff. But I think it's important to know what's going on below the hood of that before you do. Some good news, I guess, is that actually, like, we're in a really, as JavaScript developers, if you consider yourself that, we're in a really good spot for working with generative AI. There's actually a whole bunch of tooling that is built for it. And whilst the AI and the machine learning kind of industry is very Python-driven, and they do tend to get all those things first, JavaScript has seemed to be almost in second place for that kind of stuff. And obviously, again, from Steve's talk in the morning, like the .NET kind of AI essential package seems to do a lot of that stuff as well. But JavaScript, I still think, is in like second place. And we're in a good place because that gives us the ability to not just talk to the models, talk to the APIs, and talk to everything around it, but build the interfaces for that kind of thing as well. So let's start by considering our LLMs. I'm sure most people in the room have probably spoken to or used a chat bot at some point, a GPT, a Claude, a Gemini. We have those available to us, of course, by API now. And it's kind of interesting. I do think that it's interesting that now, as those applications, the consumer-side applications are kind of adding features, they move a bit further away from actually what we access in the API. And it becomes more on us to build similar or more interesting experiences with them. For the purposes of this talk, they mostly work the same. There are differences between models, and it's up to you to kind of test out those and see which ones work best for your application. I'm just going to use Gemini. It's one I found works really well for me over the API and does things that I ask it to do, which is always useful. It's also got a decent free tier to play around with as well throughout the API, so I kind of recommend having a play with that. And Gemini 2.0 Flash is kind of both quick and cheap and good. And I think that's important. Like, if you are kind of wondering which ones to play around with, there is a great site called artificialanalysis.ai, which kind of analyzes different models that are available and gives you a good kind of idea. And they're kind of top-line analysis here, and there's lots of it. But the top-line analysis is kind of over intelligence, speed, and price. And currently, like, top of intelligence on this ranking is OpenAI's O4 Mini in high functioning mode, followed by Gemini 2.5 Pro and Gemini 2.5 Flash. So those high-end intelligent ones now are the reasoning models that are starting to emerge from various places, and so are expected to, I guess, be more intelligent, but also take a lot more time. If you look then, secondly, to speed, those O4 Mini High, so that was at the top of intelligence, is now down here on speed compared to Gemini 2.5 Flash reasoning. 2.0 Flash has seemed to have dropped off of this top thing, but is also very fast, probably faster than the reasoning model. And then the final thing is price, which is also important, of course. If we're going to use a lot of these things, then price matters too. And Gemini Flash normally sits down the bottom. Gemini Flash reasoning is somewhere in the middle. And Qwen 3 reasoning, which I believe was released yesterday, is already very, very cheap and very quick. So that's kind of cool. Anyway, do check into that. There's more interesting stats and kind of comparisons on there to give you an idea of what's actually useful to use. But if you are using Gemini, Google has an SDK for using that. It's been annoying for me because they recently released a new one, this one at Google GenAI, which replaces the at Google generative AI SDK, which is almost the same but very different. And so all of these have had to be updated recently. But it is relatively straightforward to go and generate some content using Gemini. It takes you 9 lines of code in order to get something out of it. And that's just because I put some line breaks in. At this point, yeah, you can kind of just generate some content. And I did not get it to generate my talk on getting started with AI in JavaScript, I promise you. But yeah, we've got the library. You just set it with an API key. I can see you can get a free one, which is actually very cool. And then if you use ai.models.generate content, tell it the model you want to use. So this is, yeah, Gemini 2.0 Flash. It will return with a response and some text. And you can build that into an application. So I have a little demo application which we're going to kind of keep improving upon over time. And the idea is I should eventually be able to ask this chat about the event today. But right now, it is just doing straight calls off to Gemini. And so it is the base level of LLM. So if I say, hello, how are you? I like to be friendly to them. Oh, who are you? Oh, that's a nice question. That is correct. This is not giving much away. What I like to do is really ground myself by asking it things like, who am I? In which point it will come up with an answer, but best known for his significant contribution to the CMake build system. Not me. No, I've avoided C as far as I can. Definitely not the CMake build system. It's actually a former colleague of mine, also of the name Phil Nash, which has confused Google. You used to Google yourself to see if your own website or something came to the top of SEO. Now you've got to LLM yourself to find out if the models know about you. And then find out it doesn't. Very disappointing. Cool. But also, like this model, it doesn't. If I say I am Phil Nash, it doesn't care that I have anything to do with the CMake build system. It's not remembering that I've said that to it. And if I ask it now, what is my name? It also doesn't know, even though I literally just told it. This is just using that generate content function, which it's a new context every single time for the model. And so it's kind of cool. It's kind of cool. We can talk to it. We can get answers out of it. It can make up stuff about who Phil Nash is. But that's not very useful yet. Well, it's not very useful yet. We've got more to work. So it's a good thing to probably step back and have a consider how these things kind of actually work, what they're trying to do when responding to us. The morning's keynote did show us some great examples of it trying to do completion, and I agree. Like completing tokens is its entire goal, and it does so in different ways. I do like to take a look at OpenAI's example of like what tokens are, because they're not full words, or it's easy to kind of consider them to be full words, but they're not. They're actually tokens, parts of words. They're built up of the OpenAI method. It's called byte pair encoding. They build up the tokens in the vocabulary of the system by starting with just letters and looking across an entire corpus of text, and then working out where the most popular pairs of letters are. And they replace all sections with the most popular pairs with a single token, which is the two letters together. And they keep doing that with more letters and then compound tokens, building up a vocabulary that they can then generate text back out of. And that's actually important. The vocabulary matters. So GPT 3.5 and GPT-4 have a vocabulary of 100,000 tokens, where 4.0 and 4.0 mini, more recent ones, have a 200,000 token vocabulary, which means they can actually express more stuff. It's actually a factor of language. And so OpenAI gives a little example here with some text saying, many words match one token, but some don't, like indivisible, which is wonderful, which is because it is entirely divisible into two, indiv and isable. Because the token isable turns up in a bunch of different places and is more popular than the full word indivisible, which never got into being its own token. But some words are tokens, that's fine. But it's also interesting to know that if you are in the sentence that you've been generating and you get to the point where you've got the token in div, it's trying to generate the next token, and it's very likely to be isable, the next one, or other things that could come after indiv. But you're not likely to follow the token, the word part indiv with the whole token don't, for example. And so that's interesting to kind of experiment with and just see what happens. And you can kind of change up the model. So in this case, don't used to be a full token for GPT-4, but it's actually two parts of a token in GPT 3.5. Yeah, cool. And yeah, we're actually just doing fancy autocomplete. We're just doing Markov chains 130 years, or 110 years after they were invented. But much fancier, much more interesting with neural networks. And so yes, we are generating the next token in the sequence. And when we do so, it's important to note that we actually pass all the previous tokens back through the system in order to generate the next one. And so every single time you're generating you're generating a response from one of these models, it's actually doing an inner loop to pass all the tokens through the model, generate a new token, pass that one all the way through, generate a new token until it reaches its stop sequence, either something you tell it to stop on, or a token that says, this is kind of the end of the sentence, this is the end of what we've got to. There are ways of changing the behavior of picking this next token, which is important to experiment with. TopK, which is a very machine learning-y term, but we have to deal with it now. TopK is the number of tokens that you can consider when you're generating the next one. So when you're not setting a TopK, it will either have some sort of default or just kind of be all available tokens that may come next. And we are generating basically probabilities for all tokens to potentially be the next one. TopK says, let's take the top 30 tokens, say, or top 20 tokens, or top 100 tokens, and only choose from those. TopP, on the other hand, takes those percentages and says, all right, I want the top 90%, the 90% most likely of tokens. And if one token is 95% most likely, it will only pick that one. But if you have 3 tokens that are a third of the way likely each, then it's only going to pick from those top 2 that fit within that top 90. Yeah. And so slightly different ways of dealing with it. Like TopP is a variable number of tokens, but is based on the percentage, whereas TopK is just a set number of tokens. And then temperature is just like how randomly it picks within those available tokens. So it's going to pick based on the probability distribution, but the temperature, if you turn that temperature up, it can make it a bit more wild. In fact, I very much enjoy showing off it going silly when you do this. I asked it to generate a story the other day. This is Google's AI Studio. If you turn the temperature up to 2 and the top P up to 1, which just says, go wild, pick anything, but also don't limit yourself to any of the tokens, then you get nonsense. Tell me a story about happy gnome. Right. I'm not very good at generating these things. And it starts off okay. Brom Buttercup lived in Bursville Hollow, and eventually, at the end of the story, tends to go a little bit off the rails. It's going for quite an in-depth story at this point. 15 seconds worth of story. Come on, man. Let's see if we can pause there. At this point, it's getting to the point where it looks like it was a GPT-2 trained on the contents of NDC talk descriptions. Brim decided only buy this for a 2 a time. In it as 2, but those he and in together. Yeah, so it just, the conclusion, happy A or now 1 back. 5 exclamation points. Actually, sorry, it gets to, so don't ever turn the temperature all the way to 2 and take off all the other guardrails. It's not going to help you, but my goodness, try getting it to read that story to your children and see if they know what happened by the end of it. The basic idea, though, is if you are looking for the model to be a little rational and come up with mostly factual and meaningful stuff, then you want to keep that temperature down and restrict the TopK or TopP, whereas making it more creative, not too creative, but more creative, turn that temperature up and do less restriction on that. Google actually just released a paper, a 68-page paper or something, on prompt engineering, and it had some recommendations on starting points for like temperature, TopK and TopP. I presume that work best with their models, but like these kind of things are probably a little bit relevant across all kind of things. And so their suggestion was like just to start at a temperature of 0.2, TopP of 0.95, so that's 95% probabilities, TopK of 30, give it 30 tokens. And if you want it to be creative, turn that temperature up to 0.9, TopP up to 0.99, made it allow more things, but not 7 exclamation points. And TopK up to 40, but if you want it more rational, temp down to 0.1. TopP at the 90% range, and TopK of 20. That paper is linked there. I will share these slides and all the links at the end. There is a QR code, although I will admit that link is not on the details for that QR code yet. It will be later today. That prompt engineering paper is actually really interesting. And we're going to talk a little bit about actual prompt engineering in just a second, because we need to go beyond the model. We've seen that genuinely, making a call to the model, just generate content, it's easy, but it's not very useful. So we need to do more than that. The problem is that whilst models like this seem to have captured a bunch of knowledge, what they've captured is a very complicated probability distribution. And so they don't really know anything. I'd like to think, I missed Jodie's talk, which was earlier, and talking about LLMs mirroring humans. And I'd like to think that she kind of covered this in a much more sensible way, a much more intelligent way than I am. But they don't really know anything. They're just giving that illusion. I like to think of them being kind of accidentally right most of the time. But we have ways to influence them and get them to know and understand things, even that they might not have captured within their data themselves. So we need to tell them stuff. And that, yeah, it brings us to prompt engineering. Prompt engineering, I always find an interesting term. It's a very sensitive kind of thing that you're doing, basically trying to weigh probabilities in one direction or another in order to get the right result for yourself. And that's less engineering and more guessing, unless you put some kind of engineering behind it. And so whilst I don't have content on it in this particular talk, I do want you to always consider when you're trying to build with these, with models and AI that is non-determinative like this, then you should look into how to evaluate the results of your application as well. Because if you change a single word in a prompt, it could change the entire application. And you need to know how to, you need to be testing for that automatically rather than just kind of seeing what the vibes are like. But prompting does give you some options, some ways to deal with the models, and there are some patterns that you can follow at least. ZeroShot prompting is kind of how you might just talk to anything. It's just kind of asking the model for something without giving any other real context. I asked Gemini Flash 2.0 for most of these. 1.5 helped me out with one of them because it 2.0 stopped answering it the same way. But I asked, so for example, tell me a story about a friendly goblin. We already had one of those. It went off the rails. But an instruction like that gives it not much direction, but you get some result out of it, and that's nice. Pipkin was an anomaly who loved flowers. Very nice. I love that there is a probability distribution that came up with Grunglenack as a clan name. It's incredible. It's in there inside the model. Zero-shot prompting is also still worthwhile for, those factual kind of questions that you might ask. If you ask it something that it can definitely get the answer of, what's the capital of France? It knows it's Paris. If you ask the question, what's the capital of France, and it starts completing the capital of France is, that probability distribution is very hard to weigh in any other direction than Paris as the final answer. And that is what is kind of magical about these things in a way. It's everything in the gray areas where the probability is not necessarily 100% that we have to deal with. And so we can encourage it to do other stuff for us, as our morning keynote mentioned, like classifications and some, understanding the feeling behind or toxicity of a comment and things like that is great if you can give it a bunch of examples beforehand. So my prompt here, this was Gemini 1.5. Gemini 2.0 stopped doing this to me, but when I asked Gemini 1.5, just gave it an example: Australia, Canberra, France, Paris, UK, London, USA. It was like, I'm a game show host now. You got it. The answer is Washington, DC. Let me know if you want to try another country. I wasn't trying anything, Gemini. But giving it examples like that still got it to the right answer without really asking it a question. But that kind of brings us to the system prompt, because we might want to give it examples and things like that, but also drive its behavior in a way that we're not repeating every single time we prompt it. And the system prompt gives us kind of a greater emphasis on how to provide prompts to a model, but also allows us to stop repeating ourselves in all our tokens, in all our prompts. And so if I tell it in the system prompt that it's a capital city assistant and that it should be given a city, a country or a state, it should respond with the capital, then it very happily cuts out all the rest of the fluff and follows the pattern that it was given. And then there are harder challenges. I had to go looking for something interesting that would stump a model. It turns out there was a great Reddit thread of like things that models are actually pretty bad at doing. And they're kind of mostly like riddles or things that you try and get an answer out of it because it is following a pattern. In this particular case, we're taking a very classic kind of challenge riddle. A farmer is on one side of the river with a wolf, a goat, and a cabbage, and when he crosses the river in the boat, he can only take one with him at a time. The wolf will eat the goat will eat the cabbage. How does he get them all across? Is the classic. But this changes like just one thing. How can the farmer transport only the goat across the river? And so it looks mostly like the existing problem, except it's changed right at the end. And if you ask that of a model, certainly when I asked Gemini 2.0 Flash, it fully just answers the original riddle and gets that's wrong. But if you drive it using the system prompt, you can still get it to answer the same thing. But if you tell it in the system, think about your answer step by step, pay attention to the goal you're asked to achieve, that actually does drive it a bit harder. And so same prompt, but this time it's thinking about it step by step. It's thinking about the goal, and it writes down what its goal is as part of its thinking step, and is capable to now answer this correctly. It kind of says, yeah, it spits out, the goal is to get only the goat across the river, meaning the farmer needs to make sure the wolf and cabbage are together. Sure, here's the solution, take the goat across the river. Done, well done. What is funny about this is actually, I had to tweak the riddle in order to get this right answer still. And because the original post I nicked it from did not have the word only in the riddle. And having the word only made it pay attention specifically to that goal of only getting the goat across. And so most models still don't pass that test if you leave out the word only. But the chain of thought side of things, I think is really interesting. And it goes back to the way that tokens are generated one by one, always by passing in the tokens that have been generated beforehand in. Because if you get it to start generating thought patterns, those tokens then start to influence the next ones that are set out. And that kind of like loop of information going through the model and coming out with more ideas about how to solve something before it finally does helps it get to that stage. And so combining things like a system prompt, directing it what to do and telling it to think step by step, we can get it to solve interesting problems. And this is kind of this is a basic version of what reasoning models are kind of trained to do now as well. They have their thinking step before they come up with an actual answer. And this kind of brings us to chat. That has been the dominant way we interact with these right now. And chat requires some sort of memory, some sort of existence in the, some kind of understanding of the context so far. And so all we need to do is give the conversation context to the model. We can pass the entire chat back through every single time we want to continue a conversation. See, in that previous demo that I was showing, when I told it my name was Phil and then asked it what my name was, no idea. But if you set up chat, and the Google SDK actually makes it nice and easy because it stores and handles the messages for you, you can get that answer. So instead of just using a model and generating content, you can create a chat, which is going to hold the state of a conversation, and then keep getting user input, sending messages to it, getting it back, and that will then work. So if I go over here and check out version 2 of the application, I can say, hi, my name is Phil, and because the internet still works, it's nice to meet you, I can say, what is my name? And it now knows. Hooray, thank you. I wonder what it calls. If you want to call me Bill, that's fine. Okay. What if I ask it, what is your name now? Okay. I could be more forceful about that. We could put it in the system prompt that it has a name that is something, and then it would know that. But the chat there, it did display memory, at least of my name, not memory of what I wanted to call it. I shouldn't go off the script of the demos, really. So context. A full chat conversation is context. But that context is just like between what you've said and what the model has returned to you. But context is useful in more ways than that. Brings us to retrieval augmented generation. RAG is, I think, a really interesting space because models have, problems. Not just that they are non-deterministic probability systems, but they also, in terms of understanding, having knowledge or understanding of data, they have a couple of issues. One is their knowledge cutoff date. Gemini is cut off somewhere in, I think, November of last year. The GPT series are still living in October 2023, which is interesting. And so they don't know any kind of public data since then, but also they just don't know any private data. They are trained on enormous amounts of data wherever the company's got that data from, but hopefully they didn't get it from inside of your company, like private user data and things like that. But that's what's really useful for us to use these things for, to take enormous amounts of our own data and distill them and use them to answer questions, to understand our data, our users, for help users understand our platforms. Retrieval augmented generation is the way to go about kind of enabling a model with that extra data. And the idea behind RAG is relatively simple, and you can go as deep as you like with the implementation as you want. But the idea is to take that data. Apparently, I read a stat the other day that said there's enormous amounts of private data. 90% of it is just in PDFs on disk somewhere. And that's just horrifying in a way. I mean, well done, the portable document format for winning over everything. But It's very frustrating if you've ever tried to parse things out of a PDF, because it's really just a way of laying things out on a page, which means if you lay out some text over here and some over here and some over here, the order is arbitrary. Very hard to read programmatically. So we store our data. We've got to get that data out of our PDF somehow and store it. The user then makes a query to our bot. We can use that query to go and retrieve relevant data about the query. And this is the interesting part. Once we've done that, we can provide that data to the bot as part of the prompt, alongside the original query. And when we do that, the model has the capability to kind of synthesize that data and generate a response. And then ultimately, more magic happens and profit. That's what we're all after, right? I think RAG is really interesting, but like the generation stuff we've seen, it's kind of a line of code that says, here's the prompt, go on, tell me what the response is, thank you. The interesting part becomes retrieving the relevant data. It becomes a search problem, basically. And the dominant way to deal with that right now has been vector search. Vectors are, a vector is a long list of numbers, for the most part. It's a point in a multi-dimensional space. But we have machine learning models, vector embedding models that can take text or indeed other types of content. I'm just going to talk about text to make it easy for myself right now. Take text and basically distill that text down into a vector, a point in a multi-dimensional space that kind of captures the meaning of that text. It's a little awkward to think about. It's particularly awkward to think about it because these normally are hundreds or thousands of dimensions, which is something our silly, squishy brains are not very good at imagining. So here are 2 dimensions for you. And the idea here is simply like, these are 3 points in that 2-dimensional space. And we need to, and if they capture some meaning about some content, and we want to be able to compare them, imagining that like a user has made a query and we have captured the meaning of that query, and we want to find the stuff that is semantically similar to that meaning. And you might think that the 2 closest points, sort of physically, are the best ones for that. But that turns out not to be the case, because I was sort of wrong when I described a vector. It's not a point in a multi-dimensional space. It is more a direction from the origin and a magnitude, how far from the origin it is. And that direction really kind of captures the meaning, and the magnitude is just how much it means that. And so the 2 points, the 2 vectors in this particular example are the closest, are actually the ones that are pointing in the same direction, which means we can work out which ones are closest by finding the smallest angle between the vectors, and that just means we have to do some trigonometry. Thankfully, I'm not going to show you any trigonometry in this particular talk, but the metric you use is cosine similarity. It just measures the smallest angle, or how close angles are to each other. Turning content into vectors is relatively straightforward as well, thankfully. We have APIs like Gemini's API here again. You can also do it using, embedding models are much smaller than large language models, and so it is a lot easier to run them on your own hardware. And so you can do that yourself using something like the Transformers library, which was demonstrated in the browser earlier. So you can run embedding models in the browser if you want to. But if you want to do so with Gemini, you can just use a different model, basically. Use the embed content function and, in this case, Google's text embedding 004 model, a much less exciting name than Gemini, but it really does get into what it does. It's the 4th embedding model that they created. If you do that, you get a result back that has this big long list of numbers in it. Text embedding 004 gives you 768 dimensions. So that gives you an array of 768 numbers, which you can then use to compare against other 768 long arrays of numbers, which is not a lot of fun. If you do a lot of them, so doing vector multiplication on things is ultimately hard, is what GPUs are very good at. I will note, I mentioned at the start, AstroDB is our database, and one alternative method of creating vector embeddings is to let the database do so. In this particular case, if you insert a document into AstroDB, and if you've set it up with a vector embedding model beforehand using this vectorize special key here, will allow the database to actually handle vectorizing the database data for you. We include a built-in model that from NVIDIA, which means that the data doesn't leave the database to go and get embedded, as well as integrating with other APIs as well. And then it does the same for user queries, which is really useful, because if you want to then do a sort, so when you have all your data, when you have hundreds, thousands of PDFs that you've scraped and turned into data that you want to store and search through, you don't want to keep that all in memory. It is, of course, a useful thing to put into a database, and vector databases have the index that allow you to do this similarity search. And the way to do that is actually, vector search is also the wrong term. It's vector sort. You just simply sort by the things that are closest. And so that is shown here. In this database, you can just use the sort keyword. And again, if you pass the data as $vectorize, you will get it vectorized, and then that vector is used to sort the stuff at the end. There it is. So how does that look when we work with it? Well, first up, I have a database here that has, cool. Yeah, I press refresh, not contact support, right? I have a database here which has also scraped all of the content about the talks in the conference today, and so they're all there, and we've got their vectors as well. In fact, if I look at the JSON representation, we can see that the data is here. So this is accessibility and TDD. We've got all the content about Maya and Chris. Oh, that's tomorrow morning, I think. I would recommend going to that. It'd be a great talk. It's talk about test-driven development and accessibility, and then it has this vector at the bottom made up of numbers. And so that is hooked up to, version 3 of this application, which then takes a user query. That's the query that comes in from a request, and goes and does that sort using the vectorized version of the query, and then turns it into a prompt that says, it's this prompt, given the context above, answer the following question. And so it puts the contents from the database in and the question in there, another light bit of prompt engineering there to include the context and then say, hey, now answer the question. And it should do that for me. So if I do that, I can say, what is Phil Nash talking about? At the conference, not like in general, what's he going on about? He's talking about how to work with generative AI in JavaScript, hooray. And so I can ask like who else is speaking about artificial intelligence, for example. And that should give me a list of other interesting talks if you're into artificial intelligence. Steve Sanderson's giving 2. Yeah, that's a good point. Mish Duke is talking later on skills needed to thrive as a developer like this. I think I'm only returning like 4 or 5 results out of this right now. So while there might be more AI talks, my particular context only has kind of 5 results in it. So that's not maybe all of the talks about it. But that's cool. And then we can ask maybe what is happening at the party. Let's see if it knows what's happening later as well. No. Okay, it describes a technical conference, not a party. Well, good information is there is a party later and karaoke. So hang out for that. But yeah, by searching the database, by bringing back similar results, we can feed that result to the database, sorry, to the model, and have it pick out the actual answers for us. And that's retrieval augmented generation. It is important, I think, to think about the user experience of these things. And like I said at the start, as JavaScript developers, we can work at both the back end and the front end. And the user experience of dealing with models like this is kind of slow. They take ages. If we go back to our chat for a second, we have to wait for it to, let's ask it just, I'll just ask it who it is again. I have to wait and wait. It's not making big answers there for me, but what talks are about JavaScript? I've been wondering this myself. Are there any other talks about JavaScript? Just this one. Cool. No. How about what talks are about .NET? Probably a few more. We should get more of an answer at this. So it takes a little bit of time. The Gemini Flash is actually pretty quick. It doesn't necessarily show off how slow things are, but models are slow. If we were using an OpenAI model there, it would take a lot longer for that. But we do have the ability to stream responses. We actually get to take advantage of the fact that things are generated a token at a time by asking for the for the APIs to stream those tokens as they get them. And so Google make this possible in their SDK, so does OpenAI, so does everybody else. Google does it via this generate content stream call instead of just generate content. And it gives you an asynchronous iterator, which allows you to do a for-await loop, which is, I think, is very cool. For-await loops, in this case, that's just console logging, or you could just kind of write it to an open socket, send it over a WebSocket, or even an HTTP request or a response into your front end. And then when you get to the front end, you can stream that on that side using fetch, which actually I didn't know was going to be this easy. If you just have a string or a stream of text being sent to your response, as your response to a fetch request like this, then all you need to do is pass it through a couple of streaming decoders. We need a text decoder stream because the streaming response is just received as binary. The browser doesn't know what it is yet. But you can pass it through a text decoder stream and then into a writable stream. And in this case, I'm doing the easiest possible write it out to the page within our HTML, but you probably would do something a bit more sensible. And if you're doing something with React, for example, you might buffer things for a bit before you kind of let things out rather than thrashing the virtual DOM too much. But that decoder stream, that writer stream, just allow you to take the body of the response and pipe it straight through them. And I just think that's actually really nice that in 18 lines of code, you can just stream stuff to a web page. And so I upgraded our demo. So CEO number 4. And if I refresh that and say what talks are about .NET, which got a decent response from it, we now are streaming our results out. Hooray! And because the perceived performance of that, receiving the first bit of text before the last bit of text has been generated, is a much better experience for our user on that end. And yeah, rather than waiting for it to build out a whole answer for us. We did see that actually, like as we were generating our story from Gemini here. Like that was a big long thing, but we could see it streaming out. We knew it was doing something. If it just waited for 20 seconds and then spat everything out onto the page, that would have been a bit more sad. Especially because we had to wait that long to get to the number of exclamation points at the end. And then finally, the exciting thing that I think is most important for us as developers. It's sort of weird, like prompt engineering is almost something you can do with just the consumer versions of these models. And as I said, like consumer versions of the models, the kind of application version of it are doing more stuff now. They are able to search the web. They're able to gather context themselves. But building agents is something that we can do as developers. It's 2025 is the year of agents. Everybody has a different definition of an agent. So I picked some people who'd thought really hard about it to take quotes from. It turned out there was another paper from Google in about September last year where they wrote, a generative AI agent can be defined as an application that attempts to achieve a goal by observing the world and acting upon it using the tools it has at its disposal. So it can observe, it can act, and it can use tools. Similarly, Jensen Huang of NVIDIA at his keynote earlier this year said an agent is an AI that can perceive, reason, plan, and act. Yeah, perceive, reason, plan, and act. It's observing the world, it's perceiving the world. It's able to reason about it. It can think about what it wants to do, make a plan, and then act using the tools. And then in that same agents paper from Google, they describe tools as something that bridge the gap between an agent's internal capabilities, that's merely generating text, and the external world, i.e. everything that we can achieve in code as developers. And so defining tools is kind of funny. It's almost prompt engineering in itself. I always end up writing the simplest of tools to test things out with. So if you write a tool that is adding something, because we shouldn't be making models do arithmetic. They are always guessing. It's just a probability of what the next number is. But if we can give it a tool to do accurate arithmetic, like adding two numbers, it's going to be better at that. And so here's a function to add two numbers. You'll note there's a couple of things about this. One, it's returning an object as a result, an addition result. That, in some respects, tells the model, because the model gets the result handed back to it, and this is now an object that says, this is the result of the addition you asked for, those two numbers. But also, the arguments are given in an object rather than two different arguments. And we'll see why that is later, because you have to define those tools. And this is the prompt engineering side of writing functions for agents. You can end up spending more time describing that function to the agent than you actually need to write the code to achieve the task. And so Google, OpenAI, certainly are two places that mostly use a JSON schema for this kind of thing. And so this is a JSON schema definition of a function declaration, where we have a name and description at the top. We have a name and description at the top, and those are absolutely prompts. They're vital. You can't half do the name and description. They need to make it obvious to the agent, to the model, what this tool will do for it. So it makes it easiest for the model to choose the tool when it comes around to it. And then once you've got the name and description, we need to then describe the parameters it needs as well. And so, like I said, we have to pass the parameters as an object to the function, and that's because every time I've tried to use any other type in this type declaration for parameters, it just kicks me back out again unless it's object. And so you have an object, and so the object is also described as the numbers to add together. And we need both of the parameters, A and B, so you can say which are required and which are optional parameters. And then you describe all those properties as well. We describe A as a number, B as a number, and they are both the numbers that you're going to add together. And so it's a lot of work for an adding function. Hopefully you can also write a bit more complicated functions as well. And then when it comes to using them, you actually provide the definitions to the model. So in this case, this is setting up just a simple generate content using Gemini. We've got two config sections here, both tool config, which allows you to call function calling config, and a mode. So the mode actually describes whether the model has to call functions or not. I think it has options. The options are none, as in you might have functions available to you but don't call them. Any, which is you must call at least one function. Auto, which is the choice. You can call this function. You can call any of the functions or none of them if you decide you don't need them. Don't do what I've done in the past, which is always stick it to any, because if you tell it that it always has to pick a tool, it will loop forever. Just keep trying. It will keep trying. It's nice of it. And then inside the tools, you end up with an array of the function declarations themselves. So those declarations become part of the context, become part of the prompt for the model, and you can use them. And then it goes into a loop. It does loop through things. The agent receives the prompt. It's been set up with these tools in the tool config and receives a prompt. Inside, it generates itself a plan. And then it executes the plan. That is, it asks you to call those functions. So the model itself is not going to call those functions. It says, I would like you to call these functions with these parameters. You call those functions with the parameters and send the result back to the model. It receives a result. It generates a new plan. And that plan could be, I need to know more stuff. I need to use this tool now. Please call this function with these parameters. And we go in a loop. Or it can say, I've achieved my goal and return a result. And that's kind of the tool loop. It's kind of funny, and like I said at the start, I'm not a big fan of using big frameworks in order to achieve this, because it turns out that loop is only about 20 lines of code to do it kind of at the bare minimum. This is kind of written into my example code. We kind of get a prompt, send a message in the first place. I don't think I've got this. So yeah, we send a message in the first place. We kind of want to check if you've got text. If you've got text as a response from the model, it's done, and it's just spitting back text. But if it has function calls in its response, then you need to call those functions and give them back to it. And so the while loop in the middle here allows you to takes all those function calls, loops over the function calls and makes the calls to them using the parameters that it wants you to use. You get the response, you wrap it up as a function response object, and then you can be asked to call more than one function at a time in this. So you hand those function response objects back to the model at line 16, and it comes back and either has text or more function calls to do. And that is the loop. If it's got text, you're done. If it's got more function calls, we start again, call those functions, give the results back. Are you done yet? And that is kind of it. You can build, I did do that, all right. You can build stuff around it, but that is it, and it works. I didn't build it into this demo, though, because I didn't have the time. But I do have a bot running, which has a couple of tools. It has a way to search an FAQ for a bunch of made-up peripherals, IT peripherals. So I can say, my keyboard isn't working. Is it ironic to type poorly when you're trying to type the words, my keyboard isn't working? And it's going to use the tool, which is its like search information about made-up stuff, and say, all right, cool, we've got some troubleshooting steps for various keyboard-related issues, and here's some things. But it also allows you to, it also has a tool that allows it to just fetch URLs from the internet and read them. And so I can ask it things like, what is Phil Nash working on GitHub? And I haven't actually given it a URL there, and it doesn't have the URL hard-coded into the tool, but it is capable of making up a URL, and that's pretty cool because it was able to do so. In fact, I've got the code for this running somewhere. Where's it gone to? It's not that, sorry. I think it's this one. I'm going to find it because I think it's actually important to note that, yeah, that's it, tools. It's not, it's disappeared, don't worry about it. All the function did was fetch and return a text response from the fetch, it just returned the HTML. The model itself was able to fabricate a GitHub URL for me and then go and call it itself, which I think is actually genuinely quite cool. Maybe a bit too much freedom, but an interesting response from the model. I do think agents are the things we should be trying to build now. They are more useful, and you're never going to just... That's not entirely true. Sorry, start that one again. You don't always need an agent. Sometimes if you are trying to build just a system based on data, then a RAG bot or something like that will work. And you can do it with prompts and data, and that's cool. And honestly, like if that is all you need, don't build an agent out of it, because that agent loop absolutely requires 2 calls to an LLM to get at least 1 result out. Well, if it decides it wants to use a function, it's 2 calls. The call to plan, get the function result, and the call to deal with the result of that. So you are slowing things down, you're costing yourself more tokens, and you are you're not achieving more than just searching for the data in the first place and sending that as the context. But if you're doing more than that, if you want to give your application the ability to choose the way it solves a problem, then agents are the things we should be trying to build, and is probably what we're going to see an awful lot of in the near future. It is the stuff that is behind our code generating tools, applications like Cursor and Windsurf, and there are so many other places that we can use this in order to build more for the future. There are some extras I just want to run over quite quickly. Like I said, I don't believe in using frameworks when I'm learning about this stuff, but when you want to use it, things like Vercel's AI SDK is really useful. It will give you a unified interface to a bunch of models, so you can write one piece of code and use many different models just by setting that up, which is really cool. It is important to note that models act differently to the same prompt, so just changing the model is not going to magically, well, it may magically improve your application. It also may magically make your application worse. It also, Vercel being interested in JavaScript and our front ends and things like that also makes, the AI SDK makes it really easy to stream responses from basic Express applications all the way up to Next, Svelte, Nuxt, any kind of front end application you might want to use. LangChain and Llama Index are both libraries based on their original Python libraries. And so they are built originally by Python and machine learning engineers, which makes them not necessarily the most comfortable for us to use, but they are full of all of the ideas everybody's ever had about how to build with these models. They also include unified interfaces to AI providers, more stuff on data ingestion, and lots of things to interact with databases to store and search them, as well as just loads of useful patterns. One of the best things I think I've done is actually look through the LangChain documentation to find out what the available patterns are, the things that people have used these tools to kind of build the different ways people have built applications using these tools. And that kind of opens your eyes to the various different things that can be done. Like I said, like data ingestion, ways to strip out content from HTML web pages or PDFs. They're visual builders. Visual builders are really cool. Like I said, I work at DataStax, and Langflow is our visual builder. It is a open source tool, which now actually has a desktop application, which makes it easier to install than having to get the right pip and Python and things in line. And Langflow allows you to drag and drop pre-built components that you can stream together in order to build out applications, and has a built-in agent component which you can use to build things. So we have an agent component here, and it has access to two tools. In this case, again, it's a URL tool and a calculator tool. I literally just started this up, so I'm not going to try and make it do that. But I recommend checking out Langflow. It's great to experiment with those kind of things because it's cool. Then there are in-browser models. My goodness. This is very, very experimental in that Chrome has been working on, the Google team have been working on implementing a small version of a language model into the application. And yes, what's new, I know. And if we look at window.ai, yes, .language model, yes. We can use window.ai.language model. Hello. Not that. All right. These APIs change frequently, which is why it's experimental. But there is Gemini Nano, so the smallest version of Google's Gemini is being experimentally built into Canary so that you can use it within the model. Within the browser. They've also been working on smaller, more targeted AI capabilities inside the browser, which could also be really useful. So currently, which are getting closer than just the general prompting API to being available. Things like language translation, language recognition, and they're doing sort of editing, so writing and rewriting models to help people kind of write or edit content. And that kind of thing will be built into the browser, so you don't have to download a 300 megabyte model or a 2 gigabyte model in order to use these things. They're just there, or at least the user already downloaded those models because they have the browser. And so that's kind of exciting to use in the front end itself. What was a demo? So that's it. Like, now is pretty much the time to get on building with these things. Like, everybody is excited about agents right now, but we are, it's exciting. It's really interesting to see what we're going to get out of this, but more importantly for us as developers, what we can build with this as well. Understanding how to build agents, I think, is going to be a key skill as we move through the year and the next 2 years. I don't really want to think about too far in the future because everything could change, or we might just stop writing code. But now is the time to build and understand these things, see how they work, put them together, take them apart, and I can't wait to see what you do build with this. Again, my name is Nash. I'm a developer relations engineer at DataStax. You can find the slides behind that QR code, and I will be updating them with more links from this version of the talk. Other than that, find me all over the internet as Phil Nash. And I'm around for the rest of the conference and would love to have a chat with you about what you can build with these models. So thank you very much.